Our next speaker is Chayan Kumar Saha and Dimpy Adhikari. And about Chayan Kumar Saha, he's a lead QA consultant at ThoughtWork. He is having 16 plus year experience and he's based out of Kolkata. He is very active member in our internal communities. He keeps sharing his knowledge. And about Dimpy is, Dimpy is also lead consultant in ThoughtWorks. She is having around 20 years of experience as as leading QA teams, driving automation, championing shift lab studies. Welcome, Dimpy and Chain. Over to you.
Okay, hello everyone. So, how you all are feeling? So, two power-packed sessions, right? Am I audible? Okay. So, can anyone tell me, like, from the first session and the second session, the speakers actually said one common thing, both the speakers. What was that? Yeah, other than AI, sorry. Yeah. Correct. Yeah, it's about guardrails and security, right? Whenever we talk about any emerging technology comes into place, right, like AI, blockchain, we always start conversations like it should be secure, we should have guardrails in place. But do you think like security is important only for emerging technologies? Existing one also. So can we define security in one word? Is it possible? Protection, authentication, data security, anything else? Passwords, yes. If assume that all of these are in place,
also
can you say like our application is secure? Suppose that all this password protection, authorization, authentication, data security, everything in place, and you have an antivirus protecting your servers, right? Hackers are more talented. Cybersecurity, correct. So I really don't need to go back in the history lane very far. A recent, incident, and that was from a cybersecurity firm which has disrupted the entire world. July 19th. I mean, I remember the date as well. Blue screen, right? Death of blue screen happened. So one simple file, corrupted file, or you can say it was a configuration file, disrupted the entire world, right? So downtime was massive. There was loss of money, and very importantly, like loss of reputation for the company, right? So whenever we see any software problem, right? So we can go back to design patterns, coding practices, right? Clean code practices, and a lot of available materials will be there, which we can refer, right? When we have any testing problems, like you want to improve the coverage of your test cases, right? So we already have test design, a lot of test design patterns, best practices to follow. But whenever any security problems comes into picture, we have any reliable source which we can refer? Because security means like the source should be trusted, right? So that should come from an authority. Otherwise, like we cannot trust anything and everything when security comes. And that is the challenge because all other problems we have, some at least some solutions already available which we can directly use. But in the security world, right? So yes, there are some source which you can reliably offer. I know you can refer to those areas. There are security vulnerability databases which are maintained by trusted sources, which you can go back. And this talk is all about that. So over to you, Shayan. He is joining us from Kolkata, so he will be starting the presentation.
Thank you, Dimpy. Thank you for setting up the stage to start with our talk today. So, first of all, hi from Kolkata to everyone there. And as Dimpy kind of gave you already one example and kind of gave you the kind of context like on which we are going to give a talk as well as little bit demo on the best practices we have implemented. And we'll mostly focus on today on the CV part, and we'll know about more on CV and how you can utilize it and how you can get the knowledge to take care of any CVs in your application or product you're working. So I'll quickly go to the agenda. So these are our agenda today for the talk. So we'll quickly go over a few more recent examples just to understand and know the impact it can have in your application or product. And also we'll come to know about vulnerability, CV on the definition part and the kind of characteristic and other details. We'll also know a little bit on the CV system, which we have, which Dimpy already called out, like some trusted source, which we can rely on it and work on it accordingly. And then we'll also try to map it to our software development lifecycle and software quality. And we'll try to explain you how you can take care of it. Then we'll have a quick demo on it. And if time permits, we'll have a quick Q&A. Having said that, if time doesn't permit, you can reach out to Dimpy or me anytime to get clarified. So now, yeah, as already we explained myself and Dimpy, so I'll go to the next. So these are few recent examples we have like kept in our slide. There are plenty, but these are the more popular one and more familiar one, I'll say. So I'm pretty sure most of you are aware of the 2017 Equifax data breach. So Equifax, you know, it's a financial institution who does have some PII and little bit of financial data for users, which helps to give some credit score. So that data was breached due to some malicious act by some hackers, and it was kind of heavily impacted. The reputation was damaged, and it had to pay some penalty also. And again, WannaCry ransomware, you know, right? A lot of Windows computer was impacted by this, and whoever got impacted, they had to pay certain amount before they unlock their system to use for further. And in 2021, one malicious actor actually did breach the data using one flaw in the API they had, and it did steal around 500 million LinkedIn user data. And next one is Log4j, which we will see little bit more in later slide also. But I think Log4j is one of the common thing I'm pretty sure most of the software professionals used in their application or product. So it was also having a critical vulnerability which was discovered, and Apache did address those so that application and product, whoever are using it, can address it. Now, let's try to kind of define vulnerability, right? It's a word. So vulnerability, when we say like it's a kind of weakness or flaw. So it's a generic word, but today we'll focus on software development thing, mostly on this. So whenever you have any weakness or any flaw, right, in your system, which can be misused by malicious actor to do some harmful things, which can impact you in many ways, but the intention of the malicious actor will be like to damage your reputation, damage your application, and kind of impact you with respect to confidentiality or integrity or availability. So once we have any vulnerability, right, then we come to this CV thing, which we are going to give you, where you can kind of see the vulnerabilities and exposures. So this CV is kind of a DB, which kind of identify and catalog all the known and vulnerabilities and exposure, whichever found till date from any source. And it's a public data, so anyone can come and anyone can access it and anyone can use it to refer it. And this CV system actually was established back in 1999 by Mitre Corporation, and it was mostly supported by the US government. So when we talk about CV, right, it has two words. One is vulnerabilities, one is exposures. So vulnerabilities actually mostly focus on software and system issues. Exposures mostly focus on those like outdated system, configuration issues, all those things. And it's a common place where you will have everything, which is discovered so far by security researchers and other people. So when we talk about any CV, right? So generally it will have a unique identifier. When it is found and reported, it will assign a unique identifier, which will have the year which was reported by the people or any organization or any vendor. And as I already cleared out, it's a publicly accessible data for everyone. They have a lot of APIs which can be used by anyone. And it's a neutral, right? Whenever someone submits anything, they do accept it irrespective of the product, irrespective of the language. And it's a comprehensive, as I already called out, like it will have all the vulnerabilities and exposures discovered so far with a like comprehensive data on each of them. Now coming to the severity part, which is like one of the critical part to kind of act on any CV if you have in your application or product. So it's basically the impact of that flaw for your product and application. So this severity kind of decided by a like system also they have, it's kind of a framework, CVSS, which is like a common vulnerability scoring system. And it kind of varies between 0 to 10. So based on the severity, they find out based on the documentation and other things, it will be assigned a severity. So it can be 0 or it can be 10. The more the higher, the more the critical is. So it's always better if you have any critical or higher, address it quickly. So we'll discuss this addressing part later. We'll focus on the CV now. So when we talk about the CV, right? So as I said, unique identifier is there, but there are certain CVs which will have a informal name also provided by the CNS. When I'm saying CNS, this is like the common vulnerability numbering authorities. So they will assign this identifier after evaluating the documentation, evidence, and everything. And even few CVs has custom logos also. So, but those will be very rare. They generally do it so that people can get aware of it much easily, and media can kind of share it in multiple platforms so that people can be aware on it more and address it quickly. Now coming to this CVSS thing. So in actually back in 2003, 2004, it was initially kind of maintained by National Infra Advisory Council. Then 2005, it got controlled by Forum of Incidents Research and Security Team. And right now their framework version is CVSS 4.0. So they are trying to make it more accurate, more like more prominent so that it is more easily available to the users. So we came to know about the CVs, right? So we initially explained what is vulnerability. So when vulnerability will turn into CVs, like not all vulnerability will be listed in the CV database. So basically there are certain criteria which needs to be met for a vulnerability. It has to be independently fixable first of all, and it should impact only one code base. Maybe the similar kind of vulnerability can impact Java, Python, JavaScript. I'm just giving for example. So for each, there will be separate CVs entry. One entry won't be there for multiple code base. And also, of course, like it has to be documented with the security negative impact, which will be acknowledged by the dedicated authority. Then only it will qualify as a CV. So when we are discussing about the CV, right? Certainly this system is getting popularity because there are certain benefits to it to us, right? So first of all, like it will help you to know any potential risk in your system due to any of the CVs you have, right? So it will kind of help you to mitigate like faster, as well as the source is trusted. Like there are multiple sources we have, which we will again show you later, NVIDIA and CVs and Mithres. So those are trusted source. You can kind of refer them easily. Also, this having this common database in one place helps you to kind of manage and monitor it more effectively. Okay, now I'll go to the next. So now we come to know CVs, right? So how these CVs can be used by various kind of audience. So first of all, we have our software vendors, like they kind of just refer to this common database and track it and address it as applicable for their application or product. Next is we have security researchers who generally kind of report and document it when they discover any flaw in any of the things. Third is the security professionals. They are the one who work on the remediation part and assign the priority for this. Then we have some government agencies also who generally track and respond to the cybersecurity threats, which is more common and more impactful towards majority of the people. Now, as I told earlier, like about Log4j vulnerability of 2021. So this is the like little bit more details. So in Log4j, like they had a vulnerability, or I'll say flaw, using which malicious actor can execute some code remotely. Any code they can execute. So by doing that, as you know, like we have that CIA thing, confidentiality, integrity, and availability, right? They can impact any of this. Either they can steal your data, they can manipulate your data, they can impact your availability of the system. So definitely once it was discovered by the security researchers, Apache came and they acknowledged it, and they did put a fix, and they fixed it in the 2.16. So this impact and resolution will be kind of, you will get from the CVE database and other trusted advisories, right? The next action part is on us. As soon as we come to know about this, so first we have to make sure we share it with the team, prioritize it, and apply the fix. And of course, like whenever you do any change in application or product, in our QA world, we have to validate it, right? Everything is working as expected. Also, if it's like discovered little bit later by your team based on the reported date, you should review your system to check if any of the system is already affected or not. And of course, once you fix the current one, make sure you monitor it continuously so that you don't miss any of the CVs for any of the libraries, not only for Log4j, whatever is available for your application or product. So we have kind of defined the vulnerability, then we know how it turned into CV and what is the CV system, what are the benefits of having a CV system. So now we'll discuss about few impacts if you don't address it quickly, right? And or if you don't kind of address it at all. So it can impact you in many ways. So it can kind of, as I said, like it can impact you in confidentiality, integrity, and availability, right? So if you consider all of this, it will end up in financial losses, right? So you can lose customer, you can lose your trust on the customer, you can lose your reputation in the market, which will be kind of damage your reputation as well as damage your like business. Also, there are certain policies in various regions like GDPR in Europe and some other policies where you are not allowed to kind of expose any PCI or PII data, right? So you will end up in paying huge penalty to government and public, right? As well as you will kind of end up losing the customers, as well as you will lose the kind of business in market. It's a competitive one, so you may go out of business soon. So we have discussed CV and vulnerabilities. Now we'll discuss about some of the common sources which we can think from which it can be kind of misused by malicious actors, right? So of course we know input validation error, like where anyone can use this input field and do SQL injection, cross-site scripting to get access or get access to your data. And any flaw in your authentication or authorization, and which will kind of end up like having unwanted access to your application or API. Similarly, like improper session management sometimes end up in hijacking or cookie theft thing also. Also, we do have a lot of encryption for keeping this PCI, PII, or any sensitive data. So you should use proper encryption. It should not be a weak one, which can be like broke easily by malicious actors. And definitely when we implement any application or product, right, you will be using a lot of external libraries. So third-party component, you should monitor and make sure there is no known CVs listed in the database. And of course, configuration error, which Dimpy already gave you one example. So you should make sure there is no configuration error. And monitoring has to be continuous thing. and make sure you have a mechanism to verify your logs, check your logs that no unwanted access or no bot access are happening, or no kind of which is not expected for your system. So you should monitor it and report it and take proper action. And when we talk about CVs on libraries and other things, we should make sure we check our systems which we are using, software. Those are not outdated, those are up to date, because all the patch which comes in later point of time comes with a lot of security fix, enhancement, and other things. And last but not the least, definitely as a team, we can give more focus on security testing so that we can find out as soon as possible with any of the flaws we can have in our application or product. Now we'll see a few challenges of CVS. Like we already seen or discussed a lot of things related to CVEs and vulnerabilities. But having said that, there are certain challenges we have also. So first of all, it's a limited information, right? When someone reports to it, it will have little bit brief description about that vulnerability and basic reference. So you have to make sure you follow up other adversaries like vendor adversaries or any trusted database, which is that NVD thing, to get more in-depth information. And of course, like we generally, as I said, right, focus on unpatched software mostly. So we sometimes give this configuration issues, outdated system, or some even human factors, right? So we have to make sure we give proper attention to those also. And as I clearly mentioned, one vulnerability has to meet 3 criteria to make it to the CVEs. So make sure you are having proper mechanism to find out few of the vulnerabilities which can be kind of security threat for your application or product, but not listed in the CVEs because it didn't meet all the criteria, right? So if you have proper security testing, you'll end up addressing this also. Again, it's not a complete database. Like we have so many libraries and people are exploring, people are coming up with security flaws, and it will be a continuous process, right? So you cannot say that current database is enough and you can refer only that. Okay, you should always focus on all the trusted source and databases like NVD and other CVSS core system we have, and to see and address whatever severity or whatever flaw or vulnerability you have in your application or product. Now, when we talk about CV, right, as we discuss mostly on third party, right? So there will be certain CVs from some third party libraries, right? Now it's up to the vendor when they will acknowledge it, when they will kind of address it, right? So that may again end up little bit delay in your end to address it and to kind of take proper action on it. So you should arrange some temporary solution in between until the vendor is kind of addressing it. So that might delay addressing the risk you may have in your application or product. So this is the like overview of CVEs, vulnerabilities, benefits, challenges. Now I'll hand it over to Dempy back again there to give you more details how you can integrate in software development lifecycle and a quick demo. Over to you, Dempy.
Dimpy, your mic is not, you're not audible.
Sorry. Okay. So far we have discussed like, what is CV and how we can actually utilize it in our now we will see like how we can actually use it in the regular software development cycle. If you go back to the previous slides, right? So where Shan was telling like there are a lot of variations, right? So a lot of things we need to consider. If you think like, okay, we will be doing, yeah, this slide. So we'll be doing only security testing in the later stage of the software development cycle. It might be too late. So you have to really, shift the security left. Shan, can you go to the next slide? Yes. Previous one. Yeah. So right from the analysis phase, right? So you need to review the architecture from a security angle, right? So every product may have its own security need. for example, like banking or blockchain products, right? So they may need to be more secure compared to other products. So all those angles you have to bring in when you do the architecture review, and based on that, you need to do a proper threat modeling. So threat modeling should be your source of truth for the entire journey, like your how you do the proper security testing, right? So threat modeling should be a guide for you. Then when we start the actual development, like we start the coding and all, so you need to make sure like, your password, tokens, all those things are not accidentally, exposed to the repository. So you can use pre-commit code scanners like TuffleHawk, Talisman and all, so that before, whenever you are pushing any code, it's not necessarily like development code. It can be your test automation code also, right? So, and obviously we use a lot of passwords, tokens and all. So we need to make sure like, it warns you when you are pushing the code. And then you can do static analysis using like tools like SonarQube, right? So you can statically scan, and those tools will hint you or warn you like if any vulnerabilities are present in your code. And then there are post-commit code scan also, like once you commit this code to the CI/CD, when you actually build a code, right? So that point of time also you can run again one set of scanners, and it can scan the code based for your code as well as the dependencies. Obviously, like when you developed any software, right? So you will not be writing everything from scratch. You will be using a lot of third-party libraries. So how you can make sure like all those dependencies are secure? So Dependabot, Snake, and all those tools can help you to scan for all those third-party libraries. Then when we go to the actual testing phase, right, we do penetration testing or the actual security testing. We can refer the scenarios which we have identified in our threat modeling session, which is important for you to test. Along with like you can also do compliance validation. Suppose like as Sahan was mentioning, like GDPR validation or PII, PCI data validation. So all those testing, you can do it in a testing phase. Then now like we are a little bit confident, right? So we have done a lot of testing from the beginning. So, but that may not be also enough. So you have to continuously monitor your application, like using the scanners, various scanners, and you have to also see the reports, basically, whatever reports all those tools are providing. For example, like you have deployed your application, right? So, and you have also integrated maybe some observability tool like Datadog, Splunk and all, and you are seeing some sudden spike in your application, right? So whether those are from real users or those are like malicious attack or from bots. So those kind of things you can identify monitoring and analyzing the reports. And very important, like stay up to date, stay top of everything, because we'll be developing application, we'll be using next version of the different dependencies, or maybe we'll be using different tools to support the new features, right? So you have to be keep on updating your knowledge so that you can take precautionary actions. That's where the CVE system can guide us. Like you can go to the CVE database and keep updating your knowledge. And it is not possible like you have to cover all the CVs reported, but at least you can monitor the applications which you are building. For example, like your application is Spring application, so you can monitor CV for Spring, so that at least something related comes up, you are like aware of it. Next slide, please. Yeah. So this is again not a very comprehensive list of tools, but we have identified few which are relevant. And as I told, like in the pre-commit stage, right, we can use GitLab Secret. Many of you might be already aware of it. And then Talisman also can help us. Then for static analysis, we can use SonarQube, checkmarks, and Veracode. Again, Veracode is a commercial tool. And for dynamic analysis, security testing, we can use JAP or Barbsuit. Again, both have their open source as well as the paid versions. Then also you have to consider the infra security and monitoring part. You can always use like GitHub Actions if you are repository in GitHub. Then SonarQube and Sync can help. Then for monitoring, infra monitoring, you can use Rancher, Harness, or Kubernetes. Then dependency management, as I told, like, third-party libraries, you can always use Sync or Dependabot, depending on the tech stack you are in. So again, yeah, this is a very limited list I'm sharing, but yeah, this list is quite huge. Like there are a lot of other tools already available. Yeah, so far a lot of theory, right? So let's get into the demo now. So what exactly I'll be sharing, like we will go to the NVIDIA and CVE websites. I'll show you like how you can actually directly go to their website and get the details. Then NVIDIA database provides some APIs where you can use the APIs and you can get the information based. Suppose like for a specific library, you want to get the list of CVs for the last 30 days. So you can use their APIs. It is publicly available. Like if you have a limited users, you can directly hit the API. If you have like commercial use, you can use their keys and all. And finally, we will also show like how we can actually create a CV report, basically. So suppose you have connect to NVIDIA database and downloaded some list of CV details, but that has lot of information, right? So it is not very human, consumable format. So we will show you like how we can use generative AI to summarize those details so that we can consume it. So these are few references. So first, let me go to this site. So this is the CV Mitra website which Shayan was talking about. So you can always go to this website. This is a very trusted source, and the Log4j vulnerability example Shayan was explaining, right? So this is the Log4j CV ID. You can get the description and you can also get a lot of references. So these are again like community contribution. So as and when security experts and other community members contribute to this list, basically. Even if you are working on those areas, you can also contribute to those lists. And there is a NVIDIA website. This is a National Vulnerability Database. If you see the CV website, right, so details are a bit limited, right? So, but in NVIDIA has more content. And one important thing is they are providing developer access. So you can use their APIs to connect to their database and download the data. So if you go to the developers here, you can you'll have some information like how you can use the developer thing, and you can request for API key and all the information like how you can actually use their APIs, like the contract and all, everything is available in this website. So our demo also we are using this APIs. So there are multiple sources. Again, this is NVIDIA is not the one. This is again another source, right, maintained by. So here also you can see the same Log4j vulnerability. You will get more, details. And there is another one which is like cvdetails.com. Again, all these websites are like interlinked. So you'll get the same information about CVs, but with additional content. Like depending on, suppose like from one website, you are not getting all the information, you can explore all these databases. So let me go to the code now, right? So what exactly I have done to get the CV? The first step is, as I told, like it's simple. I have taken the NVIDIA API and I'm connecting to the NVIDIA API. So I can share you that. So this is the API, right? So I can give the start date and end date. and I can search based on some specific keywords. For example, like I want to search for Log4j, or I want to search for Spring, right? So I can give the specific keyword, and this API will give me the data. So how does the data look like? So I have a offline JSON file. If you see, yeah, this will give lot of data. Like as Shayan was explaining, CV ID, right? The published date, modified date, the description. Again, it has description in 2 languages. Then the metrics, and they have different versions of CV actually. So I'll show you that, like version 3 and 4. So again, some information about the CV, like what is the attack vector, like what is the score basically. As Shayan was mentioning, like no, CVs are scored. So all those information you will get it here. Yes, again, this is like a in JSON format, not in a proper readable format. So we need to parse that data to make some sense. Then I have a data parser utility, which is like extracting the top 10, because I'm getting a lot of details and I want like only top 10 list. So I am just parsing the list and sorting it based on the severity score, and I'm passing that to my GPT handler. So this is the GPT handler, and this is the prompt. I'll share the prompt as well. So this is the code which we are using. First, we need the OpenAPI key. So, and this is GPT-4. And we are summarizing the records, whatever we are getting. We are giving all the information like score, attack vector, severity, and all, and asking GPT to summarize in a specific format. For example, like I want nature of the vulnerability, then I want potential impact, and the recommended fixes basically for that. So we are creating a prompt, and we're passing the prompt to OpenAI, and we are getting the response. So in the response, all data like CV ID, date and all will be same, but the summary is actually generated by GPT. So this is the code. Let me go back to the demo now. So yeah, so this is a simple Streamlit application. So that's the simple UI. You can enter the keyword. You can give like, number of days, for example, like 120 days data I want, and maybe spring. And I'll click on generating the report. So it will take maybe 1 minute close to get the response from GPT and creating a summary report. Again, this is a live demo. I'm not sure if it is going to work. Let's see. Yeah. Wow, it works. So it gives me the list of CVs related to Spring Boot. You can see the published dates. Then you can see the severity. You can see the attack vector. You can see the summary. So this is more simpler summary than actually we got in the description. So this is summarized by GPT, like what is the nature of the vulnerability, what is the impact, what is the recommended fix. So yeah, that's all. And it is giving me the reference links. So which yeah, this is the reference link for the first CV. You can see like this vulnerability is to bypass the static resources in Webflux application. So description, then affected Spring versions, all the information, you will be getting it from here. So in the NVD database homepage also, you will get similar kind of list like, oh, sorry. Yeah. So last 20 scored vulnerability list with the severity you can see. Yeah, I think with that, like we are concluding the session. So keep yourself updated. As I told, like this is a so trusted source for getting severity of different security incidences. Many people have already contributed to that. So these lists are constantly updated. So if you see here, this is all these are latest thing. So keep updating and consider those areas in your testing so that you can make your product secure and better. Thank you so much.
Thank you, Dimpy and Shane, for the wonderful talk on the CV topic. I think it was really wonderful session for all the audience. I think we can take max one question because we are running, over the time, and this is a break time. So anyone want to ask one question? Okay.
Simply,
So
can
I
you
have one
stop
question.
sharing?
Yeah. So actually, I'm using the product, right? They have around 108 microservices there. So how can we ensure the microservice level security? And like how can get the outputs, like as a secured product with the microservice level? Can you explain about this little bit? It will be helpful for me.
Okay. Yeah, so in the microservices architecture, right, main challenge is like each service is independently deployable and each service is actually a attacker point because you will deploy your microservice in a container, right? So, and every microservice will be having their own host and port. So you have to basically consider whatever we have shared in the development cycle slide, right? So you have to consider all those things, and monitoring plays an important role here. So you have to make sure, like from day one, your services are deployed and monitored and connected to the observability tool, and create dashboard for all your services so that you can monitor it 24/7 if anything wrong happens other than your regular security testing, right? So authentication, authorization, all those things you will be testing independently. But as a product, you have to monitor it basically.
Yeah, just to add to it, Timpy, like for all microservices, as Timpy mentioned about tools, right? So in my current project, we do use Snake, where you can add the individual repo of your code base. That will kind of scan also in a regular manner as part of pipeline, which will give you the vulnerabilities you have, right, with respect to code, configuration, or any libraries. So that will even help you to point out with a consolidated report how Dimpy shows, right, using GPT, which will give you the ID, severity, and the description and how it can be remediated also. So best, and again, like it's always suggested, as I clearly called out, like high and critical should be addressed as soon as we find out about them. So it will kind of, if you can address those high and critical for individual microservices, then it will eventually make your entire product secure, right?
Thank you, Dimpy and Shane. I think you hope you got the answer. Okay, thank you.